7.2 Roots, Zeros, Solutions, and X-intercepts. We briefly talked about this in the previous video, right? About how solutions are these points where your quadratic touches the x-axis. So, just like you see in the title, x-intercepts of quadratics are also called solutions. Sometimes they're called roots, and sometimes you'll see them called zeros. So in this video, in these notes, I tried to interchange that vocabulary as much as possible to kind of just get you used to it. So just know that these are all referring to the same types of points. Now, if we have two solutions, it means our quadratic is touching the x-axis twice. That's all that means. So it could look like this, could also look like this. Just means that we have it touching the x-axis twice. So one solution, you probably already guessed, means that we have the quadratic touching the x-axis once. And it looks like it just kind of bounces right off of it. And then sometimes we occasionally will have a quadratic that starts above the x-axis and just keeps going, or perhaps it goes below and it keeps going down, right? But this option means that we have no solutions. So we either have two solutions, one solution, or no solutions. And that's what they look like, each of those different kinds. So let's look at example 1. How many roots does the function graphed below have? Well, hopefully we can use our eyeballs here and we can see that we have a solution here and here. So we've got two solutions. Oh, sorry, they're using the word roots, same thing. Two roots. What are the roots? Well, one of the roots is x equals, looks like about -5, and x equals +1. So we've got x equals -5 and x equals 1. Example 2. What are the solutions of the graph described by the equation y equals x squared minus 9? Now you don't know how to find these examples in any way except to see the quadratic, to see the graph. And I want you guys to know that that's what all I want you to do right now is just to get a picture of the graph. So where could we get a picture of a graph? Hopefully your brain just said, use your calculator, please. So we're going to type in x squared minus 9, and I'm going to look at my graph. Okay, it looks kind of like this, and I can see my solutions here look like they are at about -3 and 3. Can always double check in my table and make sure I have zeros. Like -3, I got a 0 for y, good, and +3, I have a 0, perfect. So we've got x equals -3 and x equals +3. You might also see this notation where we make a list. And remember, if they're curly like this, it's not the same as parentheses. Don't use parentheses, then it looks like a single point. We make a list. So either of these notations is fine. Okay, example 3 says identify the zeros. So have you noticed at this point that in the first one we said roots. In the second problem we said solutions. And in the problem 3 we're about to do, now they're saying zeros. Same thing, all right, same thing. They give us another function this time. And again, at this point, we only know how to find zeros from looking at a graph. So I'm going to sketch one, and I'm going to use my calculator. So we got y equals 2x squared plus 9x minus 35. And let's look at the graph. Looks like we got one way over here and like this. Okay, this is hitting right at -7, it looks like, but this one is hitting right between 2 points. I mean, it looks like it's right in the middle of the 2 points. Can you see that a little better? Yeah, it's right in the middle of the 2 points. Now, that's going to be a decimal. It's right between 2 and 3. Right? If you did want to check your table, second graph, we thought the first one was at -7. Yeah, we see a 0 here for -7, but then between 2 and 3, it goes from a positive. Yeah, we don't see it because it's going to be a decimal. So that's when we can really rely on the graph. So what I'm going to do is I'm just going to make an educated guess here. But that point is about between 2 and 3. I'm going to say 2.5. Now I'm going to show you something in your calculator that's super handy. And by all means, go ahead and you can try this in the future. I'm going to go to calc. See this word in blue right here? So I'm going to go to second calc, and I'm going to hit option 1, which says value. And this is really cool. It means it has this little blinky X right here. I'm going to type in -7 for X, and then it will tell me the Y when I click enter. You ready? Enter. Okay, Y is 0. When X is -7, Y is 0. Now I can type in another number, so I want to check 2.5. So I can just go ahead and click it. I don't have to go back to that calc menu. So 2.5. And let's see if it gives me a 0, because I need it to give me a 0. And it does. So that's just one way you can check when it's a decimal. Some of you guys also know you can just hit trace. You can just kind of get numbers like that, but that's not super helpful all the time. All right, that was a long explanation. I apologize. We got x equals -7 and x equals 2.5. And finally, I really like this problem. This problem definitely demonstrates how well you understand the quadratic shape, the parabola on the graph. This says one of the roots, so one of the zeros, one of the x-intercepts, is located at -3, 0. So right here. All right. Find the other root if the vertex is located at -1, -4. So right here. So this right here is the vertex. You're supposed to find where's the other root. So where's the other point that's on this x-axis somewhere. And this really comes down to, do you understand a parabola? What I want y'all to remember, okay, and I'm actually going to write this out. Remember, parabolas are symmetric. That's the big idea for this problem. Parabolas are symmetric. And there will be a problem like this in your quizzes. Okay, parabolas are symmetric. So, all right, I'm going to draw the axis of symmetry to help me understand this. Because it goes through my vertex, right? Splits my graph in half. So I know that the 1/2 is going to be looking like this. Now I could kind of just maybe sketch this and guess, but no. Let's think about this logically, right? If I'm 2 away from this dot right now, then on the other side of the graph, the right side, I'm also going to be 2 away, right? Because my graph is symmetrical. So this right here must be where it hits the x-axis on the other side. This must be the other root. All right, so if you get a question like this where you only get half a graph, well, if you have half the graph, you know the other half because it's going to match the side you do have. It's just mirrored, right? It's just flipped over. So that point, that missing point in this case was over 1. Okay, so 1, 0. 1, 0. All right, big ideas from this lesson today, y'all. X-intercepts, zeros, roots, solutions are all the same thing, and they're all just talking about these points. And don't forget that parabolas are symmetric.